Exercise 11F. Find the value of theta in each triangle. So the first triangle is that. This one requires you to use the concept of sine rule. And here we can say that 23 divided by sine theta should be the same as 45 divided by sine 35. So if you want to get sine theta, you can actually cross multiply, where you will multiply 23 with sine 35, and then you're going to divide them with 45. So for you to get theta, you should do sine inverse of 23 sine 35 divided by 45. So you're going to insert this on the GDC, and your answer should be 17.0 degrees. Then part B, we are still finding theta, same sine rule. We can say 4 divided by sine theta should be the same as 8 divided by sine 66 degrees. Cross multiply, you'll get your sine theta as 4 sine 66 divided by 8. And if you want to obtain theta, you do sine inverse of the answer you get on top. So when you do that using your GDC, you should be able to get your answer as 27.2 degrees. Now, part C, same thing, sine rule, 6 divided by sine theta is given by 18 divided by sine 75. So you should be very careful while choosing the sides, because you look at the side for which the angle is opposite to. For example, theta is facing this side. So you do this side, 6 divided by sine of that angle, and then this angle is facing this side. Then we do 18 over sine of that angle. So the same thing here, to obtain sine theta, you have to multiply. You multiply 6 and sine 75, then you'll divide by 18. And then if you want to find theta, you're going to do sine inverse of the answer you obtain at the top, 75 degrees divided by 18. And if you use your GDC, you'll be able to get your theta as 18.8 degrees. That's C. Let's go to D. So this angle is facing this side, and this is facing that side. So we can comfortably do 22 divided by sine theta, given by 63 divided by sine 48. We need to cross multiply to obtain sine theta, 22 sine 48 divided by 63. And if you want to get theta, you should do sine inverse of the answer you have obtained up there. And if you do this using a GDC, the theta should be 15.0 degrees. 15.0 degrees. Now, moving to part E. Part E, we're going to do the same thing. You're going to do 20, because this angle faces this side, this angle faces this side. I'm going to do 20 divided by sine theta, given by 29 divided by sine theta. Okay, for you to get theta, sine theta, you have to multiply, so you multiply 20 and sine 82, and then divide by 29. And to obtain theta, you're going to do sine inverse of 20 sine 82, by 29. And if you do this, you will obtain your answer as 43.1 using the GDC, 43.1 degrees. But if this angle faces this side, this angle faces this side, we are going to do 18 divided by sine theta is equals to 34 divided by sine 78. So if you want to obtain sine theta, you're going to cross multiply 18 sine 78 divided by 34. And if you want theta, you're going to find the sine inverse of the angle you have up there. So if you do this, sine inverse of that should give you an answer of 31.2 degrees. That's part F. And that brings us to the end of number 1. Let's look at number 2. So number 2 requires you to find the value of x. Let me see if we can have space for working out. Okay, so find the value of x. So you're going to use sine rule, and this angle is facing this side, and this side will be faced by this angle here. And then 18 degrees faces this side. So that means for us to find the x, we must first find this angle. And we can use the properties of triangles that all the angles, interior angles will add up to 180. So we are going to subtract 88 and 99 from 180 to get that one angle. Using your GDC or by just subtracting, we'll get your angle at 63 degrees. So this is the angle that faces the x. And you can comfortably use sine rule. We say x divided by sine 63 should be given by 37 divided by sine 99. For you to get x, you're going to multiply 63 on the other side. So 37 divided by sine 99 times sine 63 is what will give you x. And if you use your GDC, you'll be able to get your x as 33.4 centimeters. Okay, look at part B. You're also required to find x. Allow me to move on the side so that we have more space. Okay, let me do it down here. So part B. Part B has this angle facing this side, and then this angle facing this side. This is quite direct. So we'll do x over sine 63 is equals to 7 over sine 44. X over sine 53 is equals to 7 over sine 44 degrees. So for you to obtain x, you're going to multiply sine 53 on that side. So if you use your GDC to do this, your answer should be 8.05. Let's check if there were units. No units, so it's 8.05. Look at part C. Part C has this angle facing that side, and then this angle facing this side. That is quite direct also. X over sine 23 is equals to 15 over sine 77. So x over sine 23 is equals to 15 over sine 77. From 10x, just cross that sine 23 on the other side. So if you use a DDC, you're able to get your answer as 6.02. Did we have any measurements? No. Any units? No. Let's look at part D. but this angle faces this angle directly, and this angle faces this side, sorry, side directly. So this is quite also easy. 24 over sine 108 is equals to x over sine 33. So x over sine 33 is equals to 24 divided by sine 108. For you to obtain x, you just cross multiply. You cross that sine 33 on this other side. This will be obtain your answer using a GDC as 13.7. Any measurements given for D? No. But E, you have this angle facing that angle, facing that side. And then X, this angle here should be the one facing X because this one will face this angle. Using the property of triangle, that interior angle, sum of the interior angle is 180. We're going to see how many degrees have remained from these two. So 180 minus 122 should give you 58 degrees. So 58 degrees is the angle facing X. So we can comfortably use sine rule. X divided by sine 58 is equals to 10 divided by sine 22. For part E, we are saying X divided by sine 58 is equals to 10 divided by sine 22. So for you to obtain X, cross sine 58 this side, and then this will be sine 10 over sine 22 times sine 58. Use a GDC and you should be able to obtain your answer as 22.6. Did you have any units there? Look at part F. Part F, you have this angle facing this side and then no angle facing X. Should get that angle by using the property of triangle that the sum of interior angles is 180. So 52 plus 56, that is 180 minus 108, that's 72 degrees. So 72 degrees is the angle facing X. So we comfortably do X divided by sine 72 is equal to 6 divided by sine 52 degrees. So for you to obtain X, you cross that 6 over sine 52 degrees multiplied by sine 72 degrees. Make sure your calculator is in degree mode because you're working with degrees. Use your GDC to be able to get your X at 7.24 to 3 significant figures. Let's look at number 3. Newton and Pond stand 15 meters apart in a straight line from a tree. When they look to the top of the tree, its angle of elevation is 40 degrees and Pond's is 70 degrees. How tall is the tree? So we are going to obtain this height. That is what they're asking. The height here is how tall the tree is. Okay, so we will have this angle facing the height and also this 40 degrees facing the height. And we can actually obtain an angle that faces 15 meters, which is this angle. So always remember that angles in a straight line will add up to 180. So this angle should be 110 degrees. So 110 degrees because we have 70 here. And then 40, 110, we have an angle of 30 remaining for it to be 180, for it to add up to 180. If we do that, if we use sine rule on this triangle, we'll be able to get the capital H. Capital H is this line, which will be the hypotenuse of this other triangle on this other side, which is a right angle triangle. And then we can also either use Pythagoras theorem, or we can also use trigonometric ratios to obtain a small h. So let's do that. Let's use sine rule, which says that 15 divided by sine 30 will be equal to h divided by sine 40. So for you to obtain H, you multiply that and put it on the other side. So H will be equal to 15 over sine 30 times sine 40. So how will this help us? If we get H, we will be able to do sine 70 degrees is the same as opposite. Opposite of 70 degrees here is the height of the tree, which is small h, divided by hypotenuse, which is capital H. So, so our small h will be capital H times sine 70 degrees. And remember, our capital H is 15 divided by sine 30 times sine 40, then times sine 70 now. So put this on your GDC, so sine 70. So put this all in your GDC, and you'll be able to obtain an answer of 18.1 as the height of the tree. 18.1 meters. Quite amazing. Number 4, fire towers A and B are located 10 kilometers apart. So if this is the level ground, and this is tower A, and then this is tower B. So they are located 10 kilometers apart. B is due east of A. That means it is directly east of A, due east. Rangers at fire tower A here spot a fire on a bearing of 48 degrees. So on a bearing of 48 degrees, if you draw a true north at A, 48 degrees, because you're measuring clockwise from the north, you will go this way and you'll be able to measure 48 degrees here. 48 degrees. The rangers at B tower, at fire tower B spot the same at 334. So if you put a true north at B and you measure your angle clockwise up to 334, we will have 90 plus 90 plus 90, that is 270. And then you check how many degrees from 270 are you far from 334, and you get it is 64. So you have to measure 64 here. They should at least spot the same fire. So this angle here is 64 degrees. And remember, this is 10 kilometers. Then this is where the fire is. So how far from tower A is the fire? So we need length AF. We need length AF. Okay, so we'll need this angle here because I'm seeing if we need AF, we have the 64 degrees pointing AF. So, but we need the angle here for 10 kilometers. So if this was a bearing of 48 degrees and they add up to 90, so the true north is like this. This is 48 degrees. So there's an angle remaining here. So you subtract it from 180 because they'll add up to 90. And 90, if you subtract 48 from 90 is 42. So the angle inside here will be 42 degrees. And what is the angle up here? This forms a triangle. And the angles will add up to 180. So if you add the two available angles and subtract them from 180, you'll get that this angle is 74 degrees. So you're going to comfortably use sine rule and say 10 divided by sine 74 is equals to AF divided by sine 64. So for you to get AF, you have to multiply sine 64 to this other side. So it will be 10 sine 64 divided by sine 74. So AF should be this. If you use your GDC, your answer should be 9.35 kilometers. So we will say tower A is 9.35 kilometers from 5. So let's look at question 5. I'm going to do it on the left-hand side. Triangulation. This is a topic in year 9 can be used to find the location of an object by measuring the angles to the object from 2 points. So two lighthouses 20 kilometers apart are seen that on the diagram on the shore spot a ship at sea. Using this figure, find the distance D the ship is from the shore to the nearest tenth of a kilometer. All right. To find distance D, we can use the sine rule to do that. So we can get the angle here that faces the angle here that faces 20 kilometers. That means if that whole triangle adds up to 180 and you subtract the angle that you already used, you'll get that this is 93 degrees. So let's say we want to get this hypotenuse on the right hand side of D, so that we'll be able to use any trigonometric ratios, and especially the sine rule, the sine ratio with 38 degrees, which is opposite of hypotenuse, for us to obtain D. Okay, so with that in mind, we are going to say 20 divided by sine 93 degrees should be equal to, because we want this hypotenuse, let's call it x, will be equal to x. What is the angle facing x? Is 49, so sine 49 degrees. So for you to get x, you multiply sine 49 on the other side. So x should be equal to 20 sine 49 degrees divided by sine 93 degrees. So that is x. I do not want to obtain my answer now in terms of decimals, because my D will not be that accurate. I will want to use that answer to find D. So if I do sine 38 degrees, it will be equal to opposite divided by hypotenuse, which is x. So how do you obtain D? You multiply x to the other side, so D will be x sine 38 degrees. And remember, x is what we obtain up there. So x is 20 sine 49 degrees divided by sine 93 degrees, and then multiply by sine 38 degrees. So you can use your GDC at this point, and you should be able to get your answer as 9.31 kilometers. So 9.31 kilometers. So we can say the ship is 9.31 kilometers from the shore. So to the nearest tenth of the kilometers should be 9.3. Right. So that's the end of exercise 11F.